Hey everybody, this is Larry. This is me going over Q3 of the bi-weekly contest 37, number of sets of K non-overlapping line segments. So this one, there's a couple of different solutions. There's a couple of dynamic programming solutions with a combinatorial solution as well. I'm gonna go over the dynamic programming one and how I make the progression to solve the problem because there's a more straightforward way, but that was too long, as we'll see. So the first interpretation that I took was that I had this function, which is correct, by the way, correct, but takes too long. Why does it take too long? Well, there are n square states because there are n square possible inputs to this function, and each of them takes O of n time to calculate, so it's going to be n cubed, and n is 1,000, so n cubed is too slow. But how does this interpretation work? So basically the idea is that, okay, this is so for dynamic programming or memorization, I always ask myself, what is the question that the question is asking, right? And in this case, it is the number of sets that, given we have n spaces left and k segments, yeah, that's the question, I guess, right? So from here, let's say we have n spaces, and then the idea is that, okay, we always have to put we always have to use at least one segment for one space, and then this is actually just becomes, well, how many different possible spaces are afterwards, right? So for space is equal to 1, so this is for I is equal to 1, and then you recurse on the rest of the suffix, right? But for, let's say for I is equal to 2, then we have, one space, and also then no space, right? So so that's kind of the recurrence. I'm a little bit hand wavy here, but basically this allows you to do the dynamic programming, and then you sum it up, and then you mod it to get the answer. So why does this work, right? Again, this is just basically counting the number of possible spaces with an x to begin with, and then your base case is if we use all the segments as 0. We also would have, so that's kind of the general idea, and then the second way that we can think about it, and I kind of got stuck here for a little while. The second way that we can think about it is, okay, given in terms of, instead of thinking about segmentation of the thing, we think that this is still the same question, but we answer it in a different way in terms of recursion, right? And that's why it's kind of cool, and that's why recursion is cool and also really tricky sometimes, right? Which is that, okay, so this is the case where we put a space in this slot. So then this becomes n minus 1 and k because we didn't use any segments, right? Otherwise, we want to use the prefix, say prefix, but the beginning I characters using one segment, right? And that means that, for example, we brute force enumerate, okay, let's say we have a segment of length 1, a segment of length 2, a segment of length 3, a segment of length 4, and so forth, and with possible or no possible space in the end, which is what the recursion is for, right? This gives us the recursive answer of, okay, we filled it out, we got this, and then we're able to get this. There's some observation that you can make with respect to this, but the short story here is that, okay, what are the number of possible inputs to this, right? Well, it's still n times k, so the number of space here so the number of possible inputs is still n times k, right? And then now, and each of these still does an O of n loop. Each loop does O of n, each input does O of n work. So this is still O of n cubed because k can be n, right? So, but the thing to notice is that if we kind of look at this formula, and I wrote it here actually, then this is just the sum of this thing. And then the cool thing is that you can actually cache this in a prefix sum kind of way. And this is actually a standard E technique. I don't know if it's that standard. To be honest, it took me a little bit to even come up with it because it's been a while. I used to get all the parameters right, which is that, okay, now that we just have to cache this sum by looking at the prefix. And this is what this function that I have is. The get total is just basically this function just gets the sum of the recursive function from 0 to n k, right? And you can kind of see this formula. It takes one element at a time. It calls the recursion, and then it sums it all up. It does a little bit of mod, and then caches it in LRU cache, right? So so now total number of possible inputs, it's still n times k, but now we're doing all one work here, and I'm going to copy and paste because it's true for this as well, because now we have a loop and we compressed it into a prefix sum kind of thing, and that's what this get total does. And once you have that, we have the same parameters, and that's pretty much how you would solve it with dynamic programming. And I was going a little bit fast on the prefix sum, but basically the idea is that, okay, so let's say you have an array. Let's just say you have some array of maybe I should not, some random numbers, right? And then, so the recursion is that the sum of from zero to I is just equal to, so let's just say, you want to solve for this answer for prefix sums. It was 8. So I is equal to 8. And then that just is equal to I is equal to the prefix. If you look at the recursion, then it's just the sum of this plus 6125, which is equal to the sum of this plus 12 plus 6125 and so forth, right? So that's kind of the idea that I have for this prefix sum. There is a combinatorial answer that I actually recognized when I saw this, which is actually coming from, and this is actually from this above interpretation, which is that given this, we know that we want, this is what is known as bars and stripes, I think. I did not learn this term, so I think, and I would Google it to kind of get an understanding of it. But basically, you have n spaces and k dividers, right? For spaces. And you're trying to figure out, try to figure out how many dividers are there, and this comes up to the answer. We have to mod it, but that's pretty much it. This was a tricky problem to get right all the way through, and I think it would be hard on most days, to be honest. If it wasn't for this combinatorial answer, probably, maybe. And you could actually even solve this with dynamic programming. I think this gets actually too big, but Python, I guess, does enough optimization, enough that it's fast enough. Otherwise, I would be a little sad. Because then you could rewrite this as a DP anyway. But yeah, that's all I have for this problem in terms of explanation. You could watch me solve it live next. Silly mistakes. Non-overlapping line segments. Do I just start at 0? No. Also remember the mod, remember the mod, remember the mod, remember the mod. I think this one over, but I always forget. Why would I return the mod? That's not right. Why do I have 6? Oh, it doesn't have to go all the way, that's right. I'm double counting? Why am I double counting? This contest is just not my contest, I suppose. Why? Why am I so bad? Made that mistake yesterday. Okay. Still double counting. This can never be true. come on. Wait, that's wrong. No, is it? No, that's right. Unless I misunderstood this problem. Oh, they're allowed to share endpoint. No, How did I get 10? Oh, no, that's not right. I really think I should be undercounting. Wait, 3, 2 is equal to 4. This is wrong because something as silly as that. Now I'm undercounting. Okay, that's correct at least. I'm undercounting because I'm gonna skip ahead. Is that right? Yeah, that's too much overcounting, maybe. Spots. I also don't have a way that is in. Also, I think this is already too slow. I'm not even thinking right. Even if this is right, so I have to think about this again. I am. Oof. See, no one got in this one either. Wow. Okay, so I have to rethink this. Only 5 people have gotten it, so. I got nothing. I'm just trying random stuff. Minus. So of length 1. Wait, is it fast enough? Yeah, I don't think so. Finally got the right answer though. Almost submitted it. That 10-minute wrong answer earlier is gonna hurt. How do I optimize this? Whoops. Let's see. Do I see any patterns? I don't think so, to be honest. Actually, should not that bind. Bind them. Hey everybody, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest. I did okay, but really should have gotten that Q4. I will see y'all later. Bye bye.